Think like an astronomer. Welcome to Fresh Thinking University, where we curate the best content and wisdom from the wisest people who have ever lived. We create and curate knowledge which can inspire and equip you to become the very best person you were born to be, to accomplish and make a difference in the world. What does it mean to think like an astronomer? Have you ever looked up at the nighttime sky on a clear night and marveled at the beauty of the stars? Or seen pictures of galaxies, nebulae, or planets and wondered what they are and how we have learned about them? Or have you been outside and felt the warmth of the sun and paused, knowing it is the sun that sustains life on earth? The purpose of the masterclass is to answer the following important questions. What is astronomy? Why is astronomy important to humanity? How qualifications do astronomers need to have? How do astronomers think? Who are some of the pioneering astronomers of the past century? What can we learn from how astronomers think and ply their trade? Throughout history, humans have looked to the sky to navigate the vast oceans, decide when to plant their crops, and answer questions about where we came from and how we got here. Astronomy is a discipline that opens our eyes, gives context to our place in the universe, and can reshape how we see the world. Copernicus claimed that the Earth was not the center of the universe. It triggered a revolution through which religion, science, and society had to adapt to this new worldview. Astronomy has always had a significant impact on our worldview. Early cultures identified celestial objects with the gods. They took their movements across the sky as prophecies of what was to come. We will now call this astrology, far removed from today's astronomy's hard facts and expensive instruments. However, there are still hints of this history in modern astronomy. Take, for example, the names of the constellations: Andromeda, the chain maiden of Greek mythology, or Perseus, the demigod who saved her. As our understanding of the world progresses, we find ourselves and our view of the world even more entwined with the stars. The discovery of the essential elements that we find in the stars and the gas and dust around them are the same elements that make up our bodies has further deepened the connection between us and the cosmos. This connection touches our lives, and the awe it inspires is perhaps why the beautiful images astronomy provides us with are so prevalent in today's culture. There are still many unanswered questions in astronomy. Current research is struggling to understand questions like: how old are we? What is the fate of the universe? And possibly the most interesting, how unique is the universe? And could a slightly different universe ever have supported life? But astronomy is also breaking new records every day, establishing the furthest distances, most massive objects, highest temperatures, and most violent explosions. Pursuing these questions is a fundamental part of being human. Yet, in today's world, it has become increasingly important to be able to justify the pursuit of the answers. The difficulties in describing the importance of astronomy and fundamental research in general are well summarized by the following quote, and I quote: preserving knowledge is easy. Transferring knowledge is also easy, but making new knowledge is neither easy nor profitable in the short term. Fundamental research proves profitable in the long run, and as importantly, it is a force that enriches the culture of any society with reason and basic truth. As astronomer is a scientist in astronomy who focuses their studies on a specific question or field outside the scope of Earth. They observe astronomical objects such as stars, planets, moons, comets, and galaxies in observational by analyzing the data of theoretical astronomy. Examples of topics or fields astronomers study include planetary science, solar astronomy, the origin or evolution of stars, or the formation of galaxies. A related but distinct subject is physical cosmology, which studies the universe as a whole. Why is astronomy important to society? On a more pressing level, astronomy helps us study how to prolong the survival of our species. For example, it is critical to study the sun's influence on Earth's climate and how it will affect weather, water levels, etc. Astronomy makes unexpected significant contributions to formal and informal science education given the small number of research astronomers. Technology transfer and spin-offs from astronomy have critical applications in medicine, in industry, defense, environmental monitoring, and consumer products. What do you think an astronomer does? Well, in summary, astronomers are basically physicists that study how the universe works. Observational astronomers use telescopes to study the properties of things like the Big Bang and interpret those observations using their knowledge of physics to help us further understand the properties and evolution of the Big Bang. Astronomy is the study of the universe. Everything about the stars and planets, galaxies, dark matter, and energy. An astronomer is a scientist in astronomy who focuses their studies on a specific question or area outside the scope of the Earth. They observe astronomical objects such as the stars, planets, moons, comets, and galaxies, either observational by analyzing the data or theoretical astronomy. Examples of topics or fields astronomers study include planetary science, solar astronomy, the origin of the evolution of stars, or the formation of galaxies. Related but distinct subjects like physical cosmology, which studies the universe as a whole. Astronomy is being carried out by a young and a growing community. Traditionally concentrated in academic institutions, astronomers are now employed by an increasing diversified group of institutions. So, how does astronomy impact society? On a more pressing level, astronomy helps us study how to prolong the survival of our species. For example, it is critical to study the sun's influence on Earth's climate and how it will affect weather, water levels, and so on. One half of the US astronomers now work outside of academy. The number of astronomers working with industrial or commercial companies shows the most rapid growth, a factor of 3 over the past decade. The worldwide community of professional astronomers is only about 10,000. Most are located in the US, with about 1,000 in the UK and 250 in Australia. The worldwide community of professional astronomers is only, as I indicated, only about 10,000. Now, the Astronomical Society of Southern Africa was formed in 1922, and it's an overall body consisting of both amateur and professional astronomers. There are 8 autonomous centers throughout Southern Africa. Various sections exist within the society to coordinate the activities of special interest groups, including the running of observational programs. A national symposium is organized and held every second year. SCOPEX, a significant public outreach event, is held every year under the auspices of the Johannesburg Center. Astronomers have to gain 3 types of knowledge: information, skills, and wisdom. Amateurs can gain aspects of this knowledge, but they do not go through peer review experienced by professional astronomers. Instead, astronomers collaborate with experts from other disciplines to develop new instruments. The interaction expertise is a valuable tool and a platform for astronomers at their disposal. Astronomy is the oldest of the natural sciences. Astronomy is the only science in which you cannot perform experiments directly. You cannot weigh, touch, or smell your subject matter. You can only observe the radiation, visible light, radio, infrared, which comes to Earth. What do astronomers do? Most astronomers concentrate on a particular question or area of astronomy. For example, planetary science, solar astronomy, the origin or evolution of stars, or the formation of galaxies. Observational astronomers design and carry out observing programs with a telescope or spacecraft to answer a question or test the predictions of theories. Theories work with complex computer models of a star's interior. For example, to understand the physical processes responsible for the star's appearance. Astronomers no longer look through an eyepiece on their telescopes, but instead use sophisticated digital cameras attached to a telescope and computers to gather and analyze research data. The actual time spent at a telescope collecting data for analysis is only the beginning. Astronomers spend their time in an office analyzing the data. Creating computer programs allows them to search through the data, write research papers, and complete other administrative tasks more efficiently, like attending meetings. Many variables shape an astronomer's time. So many work flexible hours that meet their unique job environments. Want to become an astronomer? What classes to take at high school? Well, maths, science, computing, and maths are compulsory. Regardless of whether you are going into sciences, your background will provide valuable skills that transcend any discipline. Taking classes that provide a solid foundation for research, writing and presenting papers are invaluable. Becoming a skilled communicator on paper and in person will always serve you well. Choose electives and outside organizations that will round out up your education. If you are confident that astronomy is the field for you, be prepared to accomplish your end goal. What classes to take at college? Well, most astronomers have their PhD in astronomy or physics. In addition, about 100 US colleges and universities offer a PhD in astronomy, and many more that offer other undergraduate degrees in physics and astronomy, astrophysics, or mathematics. Since college is a considerable investment of time and financial resources, but also essential to consider more than just the location when selecting a school. Today's students should investigate the following: school and classroom size, school and departmental culture, availability of financial aid, the number of staff publishing papers in professional journals, and the types of varied research experiences available to the students. Manage your future wisely. Graduate schools are competitive, so it is essential to maintain top grades as undergraduates. Students must take the graduate record exam before being admitted to any graduate school. Many astronomy programs will request the GRE in physics. Once in graduate school, students spend time completing advanced coursework in astronomy and focusing on their research, specifying a thesis topic and beginning the dissertation is the next. Conducting the research, writing and defense for a dissertation are the final steps to completing the PhD. The entire educational journey, undergraduate, graduate, through the dissertation can easily take 9 to 10 years. One needs to be dedicated, patient, and passionate about the science of astronomy. Jobs for astronomers. Because astronomy is a relatively small field but attractive to many students, there is a significant competition for jobs. For example, it is common to take a postdoctoral position after obtaining a PhD. This temporary appointment allows an astronomer to concentrate on research, publishing papers, and building their reputation in the field. In addition, astronomers may accept more than one postdoctoral position today before applying for jobs in academia. The national observatories, national laboratories, or in private industry. Jobs for non-astronomers. What type of jobs are available for individuals who like astronomy but do not want to be astronomers? Every kind. There are telescope operator technicians. There are trades. They include carpenters, electricians, mechanics, etc. There are administrators. There are engineers. There are educators. And there are groundskeepers and janitors. The list goes on. Most observatories, laboratories, colleges, and universities have employment pages to search through for jobs that may fit your skill set. Historically, astronomy was more concerned with classifying and describing phenomena in the sky. At the same time, astrophysicists attempted to explain these phenomena and their differences using physical laws. Today, that distinction has mostly disappeared. An astronomer and astrophysicist are interchangeable. Professional astronomers are highly educated individuals who typically have a PhD in physics or astronomy and are employed by research institutions or universities. They spend most of their time working on research. However, they often have other duties such as teaching, building instruments, or aiding in the operation of an observatory. The American Astronomical Society, the major organization of professional astronomers in North America, has approximately 10,000 members. This number includes scientists from other fields such as physics, geology, and engineers whose research interests are closely related to astronomy. The International Astronomical Union comprises almost 10,000 members from 70 countries involved in astronomical research at the PhD level and beyond. Portrait of the Flemish astronomer Ferdinand Verbiest became head of the mathematical board and director of observatory of the Chinese emperor in 1669. Contrary to the classical image of an old astronomer peering through a telescope through the dark hours of the night, it is far more common to use a charge-coupled device, CCD camera, to record a long, deep exposure. They allow a more sensitive image to create because of the light added over time. Before CCDs, photographic plates were a standard method of observation. Modern astronomers spend relatively little time at telescopes, usually just a few weeks per year. Analysis of observed phenomena and making predictions about the causes of what they observe takes most observational astronomers' time. Astronomers who serve as faculty spend much of their time teaching undergraduate and graduate classes. Most universities also have outreach programs, including public telescope time and sometimes planetariums as a public service to encourage interest in the field. In high school, those who become astronomers have a broad background in maths, sciences, and computing. Taking courses that teach how to research, write, and present papers is invaluable. In college and university, most astronomers get a PhD in astronomy or physics. Amateur astronomers. While there is a relatively low number of professional astronomers, the field is popular amongst amateurs. Many cities in the US and Europe have amateur astronomy clubs that meet regularly and often host star parties. The Astronomical Society of the Pacific is the largest general astronomical society globally, comprising both professional and amateur astronomers and educators from 70 different nations. Like any other hobby, most people who think of themselves as amateur astronomers may devote a few hours a month to stargazing and reading the latest developments in research. Amateurs span the range from so-called armchair astronomers to the very ambitious, who own science-grade telescopes and instruments to make discoveries and assist professional astronomers in research. Historically, few astronomers have been significant because of gender bias and limited resources allocated for gender parity. For example, the percentage of women in astronomy has grown by almost 50% during the last decade, from 8% to 12%. However, examination of the graduate student population shows signs of a slow, continuing growth in number of women in astronomy. Recent surveys further shows that 12% of the doctoral degrees awarded in astronomy departments, for example, 1987, went to women. That 20% of the total astronomy graduates population is female. The types of jobs that astronomers now occupy have changed over the last decade. Traditionally, an astronomer achieved a permanent job on the tenured faculty at a university or college. In addition, industrial and academic research jobs were considered less desirable due to their perceived impermanence and lack of academic freedom. The rapid growth of astronomy in the late 1960s and the concomitant youthful age of astronomical faculty have meant that faculty retirements have been few and far between. This has, in turn, severely limited the number of tenured faculty jobs that opened up during the last 10 years. As a result, industrial and national research facilities have taken up much of the slack by employing many astronomers who still carry out astronomical research. Academic institutions still provide jobs for half of the American Academy of Science members. Still, other types of employment have become more critical. For example, nearly 75% of the employed in academia hold permanent tenure jobs, exclusive of astronomers holding postdoctoral appointments. 17% of the academic astronomers have positions as research associate. From astronomy to the aerospace sector. What does that mean? The aerospace sector shares most of its technology with astronomy, especially in telescope and instrument hardware, imaging and image processing techniques. Since the development of space-based telescopes, information acquisition for defense has shifted from using ground-based to aerial and space-based techniques. Defense satellites are telescopes pointed towards Earth and require similar technology and hardware to those used in those astronomical counterparts. In addition, processing satellite images use the same software and processes as astronomical images. Technology transfers from astronomy to industry. Some of the most valuable examples of technology transfer between astronomy and industry include advances in imaging and communications. A great example is a film called Kodak. This is used extensively by medical and industrial spectroscopists, industrial photographers, and artists, and was initially created so that solar astronomers could record the changes in the surface structure of the sun. The development of the technical plan was used for several decades to detect diseased crops and forests, in dentistry and medical diagnosis, and for probing layers of paintings to reveal forgeries. Skills required to become an astronomer. If you are an aspiring astronomer, the information in this masterclass can help guide you on your path towards lucrative career in this very exciting and growing industry. We appreciate you coming over, and we promise that only the very best content ever will be put on this platform. To continue your journey with Fresh Thinking Master Classes, hit the subscribe button on the YouTube platform. Let us know what inspires you and how best we can serve you on this platform. Hit the subscribe button and be the first person to get new content from this platform. As a leader aspiring to think like an astronomer, what are the 3 key lessons you learned from this masterclass? How can you apply the lessons to improve the quality of your life? What are the 3 specific actions you plan to take in the next 24 hours? I'm glad we journeyed together during this masterclass. We appreciate you coming over, and we promise that only the very best content ever will be put on this platform. To continue your journey with Fresh Thinking University Masterclasses, hit the subscribe button on the YouTube platform. Let us know what inspires you and how best we can serve you on the platform. Hit the subscribe button and be the first person to get new content from this platform. Signing off, Dr. Masasekani Mishak Kosa, the Thinking Futurist. Thank you.